A warm good morning to all students. Welcome to the 44th lecture of fluid mechanics subject. So, since 1 week, we are in the unit 3 topics. So, in yesterday's class, we have discussed about flow through pipes in series and equivalent pipes and their associated problems with the derivation. Today, in this class, we will discuss about the flow through pipes in parallel connection. So, we will discuss the concept of flow through pipes in the parallel connection and also the derivation of these parallel connection pipes and also the problems associated with these pipes. So in this unit, so we have completed the concept of pipes in series. Now we are dealing with the pipes in parallel concept. The total energy line and hydraulic gradient line is also already completed in 42nd lecture. So within 5 or 6 classes, we can complete the unit 3 topics. Yes. So we'll start the class. Yes. So in the last HGL and TGL and also the pipes in connections pipes in series connection, we have dealt with some of the formulas. So till the end of this unit, so I will showcase the formulas so that you will be aware of knowing the formulas where we have to use and which concept we have to apply. So the major losses formula is, first one is the Darcy-Varshy formula, Darcy formula, and the second formula is the SES formula, that is V is equals to C into root Mi, right? So these are the notes for that. Next, coming to the minor losses, we are having 7 types of minor losses. In that minor losses, we are having expansion of pipe, contraction of pipe, uh, obstruction in the pipe, bend in the pipe, uh, entrance of the pipe, exit of the pipe, and also the pipe fittings. So based on that, every case you are having the formula. So if you see the sudden expansion, the formula is HC is equals to V1 minus V2 whole square by 2G. Okay, so where V1 is a velocity in a small pipe, V2 is a velocity in the large pipe. Next, second one, the loss of head. The loss of head due to the sudden contraction. The loss of head due to the sudden contraction, that is HC is equals to 1 by Cc minus 1 into V2 square by 2G. So when C is considered, that is coefficient of friction, the value is this one. When C is not considered, we are taking 0.5 V2 square by 2G. Yeah, small disturbances. Yes. Next, the loss of head at the entrance of the pipe. The loss of head at the entrance of the pipe, HI is equals to 0.5 into V2 V square by 2G. So that is at the entrance of the pipe. This is at the exit of the pipe. H naught is equals to V square by 2G. V square by 2G. Next. Next, we have discussed about the HGL and TEL. So it is the line representing the sum of the pressure head, datum head with respect to some reference line is known as HGL, whereas the line represent the sum of the pressure head, datum head, velocity head with the some reference line is known as TL. Okay, next. When the pipes are different lengths, and different diameters are connected end to end, these pipes are called as pipes in series or compound pipes. The rate of flow through each pipe connected in series is same. Next. A single pipe in a uniform diameter having the same discharge and same loss of head as compound pipe consisting of several pipes of different lengths and diameters is known as equivalent pipe. So the diameter of the equivalent pipe is called equivalent size of the pipe. So till here we discussed the problems and also we have derived the derivations and also we have got the formulas. Based upon the formulas, we have dealt some of the problems. Now we are going into the pipes, flow through pipes in parallel connection. So in the last class, we have discussed about the series connection. We had the formulas and also the concept of equivalent pipe, where you are having different pipe lengths and diameter, and the total length is L is equals to L1 plus L2 plus L3, where H is equals to loss of head is equals to L1 pipe lopala the friction, L2 friction, L3 friction. Therefore, F is same coefficient of friction F. Thereby, the formula can be written as L by d phi is equals to L1 by d1 phi plus L2 by d2 phi, L3 by d3 phi. This is known as Dupix's equation, right? The equivalent pipes formula is also known as Dupix's equation. Next one. Three pipes of length 800 meters, 500 meters, 400 meters, and diameters 500, 400, 300 respectively are connected in series. These pipes are to be replaced by the single pipe. Until initially, these are connected with the three different pipes with three different lengths. Now it is replaced with a single pipe of 1700 meters. Therefore, what is the diameter of the single pipe? So when these problems you are facing in an exam, you have to conclude that is a equivalent pipes concept. Therefore, the length of the pipe L1 is equals to 800 meters and diameter is 0.5 meter. The length of the pipe 2 L2 is equals to 500 and D2 is equals to 0.4. The length of the pipe L3 400, D3 is equals to 0.3. Therefore, the length of the single pipe L is equals to 1700. Therefore, let the diameter of the equivalent single pipe is equals to, we have to assume the diameter of the pipe, single pipe is D. Then applying this formula, the equivalent formula, this formula, L to the power L by d to the power of 5 is equals to L1 d to the power of 5, L2 d to the power of 5, L3 d to the power of d3 to the power of 5. Therefore, 1700 divided by d to the power of 5 is equals to 1800 by d1 value, 500 by d2 value, 400 by d3 value. Now, solving this all these rational numbers, we are getting the value. Therefore, d to the power of 5 is equals to the ratio. We are getting this one. Therefore, the diameter D is equals to 378.8 mm diameter. So like this, you have to solve the problem when you come across any equivalent pipes. Okay, next one. Now we'll start the flow through the pipes in parallel connection, right? Now see this pipe here. So here the velocity of fluid is flowing. Here the velocity of fluid is coming out of the pipe. Now this is a branched pipe. See here, this space is a empty space. The fluid is flowing in this direction. The fluid is going in this direction. So fluid మనకి ఇలా వెళ్తుంది, ఇలా వెళ్తుంది. Okay now. Consider a main pipes. Consider a main pipe which divides into two or more branches shown in the figure, and again join together downward stream to form a single pipe. Then the branch pipes are said to be connected in parallel. So what is the meaning of the sentence? The pipe is like this and that it is taking the other direction. Okay, this is the pipe and it is taking this direction. Okay, so in this direction again they are moving to some extent, and again they are connecting at some point. Again they are connecting at some point like this. And again they are traveling in a same pipe connection. Therefore, the fluid is flowing in this direction. The fluid can flow in this direction, but they are meeting at the other point and coming out of the pipe. This type of connectivity we are calling them as the pipe is said to be in parallel. The pipe is said to be in parallel. Okay. Next, the discharge through the main is increased by connecting the pipes in parallel. The discharge through the main is increased by connecting in the parallel. So whenever the pipes are connected in parallel, the discharge of the water will increase, right? So whenever the pipes are connected in series, the discharge may be, you are getting the differences, depends upon the diameter, right? So now just draw the figure. So this one is L1 pipe. The length of the pipe is L1, the diameter of the pipe is D1, and the velocity of the pipe is V1. Here, the length of the pipe is L2, the diameter of the pipe is D2, the velocity of the pipe is V2, right? This is a branch pipe 2, this is a branch pipe 1. Okay, now this is a discharge Q1, the discharge Q2. Okay, so just draw the figure, and the rate of flow in the main pipe is equal to the sum of the rate of the flow through the branch pipes. So whenever the rate of flow Q is equals to how many branches? For example, if you're having 3 branches, it is Q1 plus Q2 plus Q3. So if you're having 2 branches, then Q1 plus Q2. So in this arrangement, the loss of head for each branch pipe is same. So the head loss HF is same for the each branch. Therefore, the loss of head for each branch pipe 1 is equals to loss of head for each branch pipe 2. The loss of head for branch pipe 1 is equals to loss of head for branch pipe 2. Now, so taking this equation, loss of head at 1, loss of head at 2, we will write the old formula, that is 4 into F1 L1 V1 square by D1 into 2G, that is equal to 4F2 L2 V2 square by D2 into 2G. Therefore, the F1 is equal to F2. Therefore, L 4F cancel just. Therefore, L V1 square by D1 2G is equals to L V2 square by D2 into 2G. So this is the formula for pipes in parallel connection. Pipes in parallel connection. Okay. Now, based upon this formula, we'll solve some problems. Some problems are simple, some problems are complicated. Okay, so we'll solve minimum problems and we'll have some practice. Yes. Now see the first problem here. See the first problem. A main pipe excuse. A main pipe divides into 2 parallel pipes. Okay, which again forms one pipe as shown in the figure. So this is a figure. Where is the figure? Okay. So I think so. This may be the figure. 11.17. Yes, this is a figure. Okay. The length and the diameter of the for the first parallel pipe is 2000 meters, 2000 meters, and 1 meter respectively. Right. So the length and the diameter of the first parallel pipe, length is 2000 meters, diameter is 1 meter. While the length and diameter of the second parallel pipe is 2000 meters and 0.8 meter. Find the rate of flow in which find the rate of flow in each parallel pipe. Ante Q1, Q2 కనుక్కోమన్నాడు. If the total flow in the main pipe is 3 meter cube, so total Q is equals to 3 అని ఇచ్చాడు. Therefore, the coefficient of friction for each parallel pipe is same. F1 is equals to F2, that is equals to 0.005. So that's why I'm saying that. So study the question, read the question minimum 2 or 3 times so that you can understand from which unit it has been given. So generally, part below, you will get the questions accordingly, according to unit wise. There is no worry in identifying the what type of question. But one thing is, in the unit, for example, if you are getting part 2, the part 2, second, third, right? So first part 1 is first question in that A, B, C, D, E, F, G, H. In the part 2, you are getting 2, 3, 4, 5, 6, 7, 8, 9, 10, like this. So you have to check in the third unit what type of question is given. If it is given in the series type or parallel type, or maybe some other minor losses or major losses. Okay, now write the given data. The length of the pipe L1 is equals to 2000 meters. The diameter of the pipe D1 is equals to 1 meter. The length of the pipe L2 is equals to 2000 meters. The diameter of the D2 pipe, the diameter of the pipe 2 is 0.8 meter. Then what is the total flow? The total flow is given as 3 meter cube per second. Therefore, what is the rate of flow? F1 is equals to F2 is equals to F is equals to 0.005. Let what is the things you find? So let you can write, or find also you can write. Let Q1 is equals to discharge in the pipe 1. Q2 is equals to discharge in the pipe 2. Therefore, according to the initial derived formula, that is E formula, this one, discharge, total discharge. Therefore, Q is equals to Q1 plus Q2, that is equals to 3 is equals to Q1 plus Q2. Now, taking this formula into consideration, 4 into 4 into F1 into L1 into V1 square by D1 into 2G is equals to 4 into F2 into L2 into V2 square by D2 into 2G. Now substituting by taking this formula, substitute here 4 into 0.005 into F1 is equal to 0.005, L1 is equal to 2000, V1 మనకు తెలియదు కాబట్టి V1 by D1 ఎంత 1 meter 2 into 9.81 is equals to 4 into F2, L2 value, V2 square, ఇక్కడ square ఉండాలి కట్టలేదు, okay, by 0.8 into 2 into 9.8. Therefore, after substituting all this one, V1 square by 1 is equals to V2 square by 0.8, or V1 square is equals to V2 square by 0.8. Therefore, V1 is equals to V2 by root of 0.8, that is equal to V2 by 0.894. So keep it as separately. Next, so what is a Q? Q is equals to pi by 4 d4 into V1. The area into velocity. Therefore, Q1 is equals to pi by 4 d1 square into V1, that is equal to pi by 4 1 square into V1 plus లో ఇది substitute చేయండి. Thereby we know that this value. Okay, next Qt is equals to same formula apply చేసి, therefore pi by 4.8 square into V2, that is equal to this one. Now substituting the value of Q1 and Q2 in previous one. Which one? This one. So ఇక్కడ ఉంది కదా, now substitute the values of Q1 value, Q2 value. ఈ ఈక్వేషన్ లో ఆ వాల్యూ సబ్స్టిట్యూట్ చేయండి. therefore Q1 plus Q2 is equal to 3, అంతే కదా, Q1 plus Q2 is equal to 3. So therefore what is Q1? V2, this one, pi by 4 1 square into V2 by 0.8. This one is Q1. ఇది వచ్చేసి Q1, ఇది వచ్చేసి Q2 is equal to 3, or దీన్ని సపరేట్ చేసేసి, సో V2 సపరేట్ చేసి వాల్యూస్ అన్ని పక్కకు తీసుకోండి. then the value of V is equals to 2.17 meter per second. That is a velocity. Now ఏం చేయాలి? Now substituting this value in equation 2. Then what is equation 2? This one. Now substituting this value, V1 is equals to V2 by 0.894. Therefore 2.17 by this one, value of V1 is equals to 2.427. 2.427. This one is V2. వాళ్ళకి రాయలేదు V2. Now we got V1 value, and V2 value. Now therefore Q1 కనుక్కోండి. So pi by 4 d1 square into V1 అంటే pi by 4 into 1 square into 2.4, that is equal to 1.906. The same way Qt is equals to pi by 4 d4 into d2 square into V2 ఏం చేసుకున్నా కూడా we'll get Qt value. Or you can subtract like this, Q2 is equals to Q minus Q1, that is equal to 3 minus 1.9. ఇలా చేయొచ్చు. లేదంటే Q2 తీసుకొని pi by 4 d1 d2 square into V2 తీసుకున్నా కూడా you'll get the velocity. So like this you have to solve the problem for this pipes in parallel connection. So I hope this problem solving is very easy, right or wrong? I think it's understood. So simply ఇక్కడ ఏం చేశాడు, given data as it is తీసుకున్నాడు. So as per formula total discharge is equals to Q1 plus Q2 రాసుకున్నాడు. తర్వాత ఏం చేశాడు, ఇక్కడ ఏం కనుక్కున్నాడు, find the rate of flow in each parallel pipe with the total is this one. So Q కనుక్కోమన్నాడు, Q1 లో ఎంత ఉంది, Q2 లో ఎంత ఉంది కనుక్కోమన్నాడు. Before that you have to calculate the value of V1 and the value of V2. అప్పుడు వచ్చిందండి Q1 లో సబ్స్టిట్యూట్ చేస్తే you are getting Q1 value is this one, Q2 value is equal to this one. Therefore Q1 plus Q2 is equals to total discharge. So ఈ రెండు యాడ్ చేశారనుకోండి, you are getting the value 3. Therefore Q is equals to Q1 plus Q2. So like this you have to solve the problem. Next we'll go with the second case. A pipe line of 0.6 meters diameter. A pipeline ఎంత ఉంది, that is 0.6 meter diameter, is 1.5 kilometers long. So don't, while studying the question, you keep the units in mind. So centimeters లో ఇచ్చాడా, meters లో ఇచ్చాడా, kilometers లో ఇచ్చాడా. So here it is given the kilometers. So what is the pipe length? 1.5 kilometer. And what is the diameter of the pipe? 0.6 meter. Now to increase the discharge, another line of the same diameter is introduced parallel to the first pipe in the second half of the length. So, what is the condition here? In order to increase the discharge, the pipe local discharge in పెంచడానికి another line of the same diameter, same 0.6 meter diameter తీసుకొని is introduced parallel to the first in the second half of the length. అంటే ఇప్పుడు for example, if you see the pipe length is like this 0.6 diameter, తో this is 1.5, this is 1.5 తో this is 1.5 kilometer pipe. సో దీనికి parallel గా సేమ్ డయామీటర్ పైప్ తీసుకొని సెకండ్ హాఫ్ అంటే ఇక్కడ నుంచి సెకండ్ హాఫ్ నుంచి స్టార్ట్ చేశాడు. Neglecting the minor losses, find the increase in the discharge. Find the increase in the discharge if 4F is equals to 0.04. The head at the inlet is 300 mm. There is the condition, right? So I think this problem you're having lengthy issues so that you can understand what's happening in reality. So the first pipe, the second pipe. Okay. So the diameter of the two pipes are same. Now what's the given data? Write down the diameter of the pipeline. The diameter of the pipeline is D is equals to 0.6 meter. Okay, na? The diameter of the pipeline D is equals to 0.6 meter. Next, the length of the pipeline. The length of the pipeline L is equals to 1.5 kilometer. Convert into meter. That is 1500 meters. తర్వాత ఏమి ఇచ్చాడు condition? 4F is equals to 0.104 or F is equals to 4 discuss the F is the value 0.01. Then what is the head inlet? H is equals to 0.3 meter. Therefore inlet ఇచ్చినప్పుడు outlet ఇవ్వనప్పుడు ఏం చేయాలి? We have to assume that towards the atmosphere. Therefore outlet is atmospheric head 0. Therefore head loss is equals to ఎంత? The head loss is HF is equals to 0.3 meter. Now the length of the other parallel pipe ఎంత? L1 is equals to 1500 అయితే the other length pipe, sorry, this one is okay. Common length of the pipe this L, the length of the other pipe. So ఇక్కడ don't get confused. ఇక్కడ మీరు L1 అని వేసుకోవచ్చు, L2 అని వేసుకోవచ్చు. ఇక్కడ L వేసుకున్నారు కాబట్టి మీరు L1 అని పెట్టుకోండి. Therefore half అన్నాడు. చూడండి, second half of the length. The first in the second half. So therefore 1500 by 2, second pipe length is 700 meters. Now what is the diameter of the parallel pipes? Diameter is the same pipe. Therefore just draw the figure. So the first diameter length is same. The diameter of the pipe is 0.6 meter. Okay, the first length the length of the pipe is 1500 meter. Correct ga center తీసుకున్నాడు. Center తీసుకొని తర్వాత ఏం జరిగింది? The pipe diameter has been reduced. The pipe diameter has been branched. So center నుంచి L1. So total length is 1500, L1 is అందులో 700, L2 is 700 and the diameter is same 0.6 meter and 0.6 meter. So actually ఈ స్పేస్ చూపించాడు ఇక్కడ, కానీ తక్కువ చూపించాడు. There is no problem. So the diameter, the discharge Q1, the discharge Q2 and the discharge Q. Okay. Now what is the head loss? ఎంత అన్నాడు? The head loss is 0.3 meter. 0.3 meter from the center of the pipe. ఎప్పుడైనా సరే center of the pipe నుంచి మీరు dimensions తీసుకోవాలి. Head loss is 0.3. So entrance of ఇక్కడ ఏమన్నాడు? Neglecting the minor losses అన్నాడు. Minor losses అంటే ఏంటి? Contraction, expansion, entrance, exit. సో అన్ని తీసేస్తాయి. సో దట్స్ వై మనకి ఇక్కడ పాయింట్ A, నెక్స్ట్ ఎక్కడ కట్ అయింది? పాయింట్ B దగ్గర కట్ అయింది. సో పాయింట్ B కంటిన్యూషన్ C వరకు ఉంది, పాయింట్ B దగ్గర కంటిన్యూషన్ సెకండ్ పైప్ D దగ్గర ఉంది. Now take the first case. This is the first case, this is the second case. Now taking the first case into action, discharge for the single pipe for length 1500 meters and diameter is 0.6 meter. The head lost due to the friction in the single pipe HF is equals to 4 into F into L into V square by D into 2G. Okay, the head loss formula where V star is equal to velocity of flow for single pipe. So velocity of flow, so ఒకే పైప్ కాకుండా ఫస్ట్ పైప్ తీసుకున్నాం, సింగిల్ పైప్. Therefore apply the value 0.3 value is equals to 4 into 0.01 into 1500 into v square 0.6 into 2g. Therefore v star is equals to, when we simplify cheste, is equals to 0.2426. Now take the discharge of the first discharge. Q is equals to v into area. V value ఇక్కడ వేయండి. Area is equal to pi by 4 d square, that is equal to 0.0685 meter cube per second. ఇది ఫస్ట్ కేస్ అనుకుందాం. ఓకేనా? There is a first case. That is a first case. Now taking the second case, when additional pipe of length, additional pipe size is second case. When the additional pipe of length 750 meters and the diameter 0.6 meters is connected in parallel with the last half length of the pipe అన్నాడు. సో ఇది మనకి అయిపోయింది. నెక్స్ట్ ఏం తీసుకోవాలి? ఇది తీసుకోవాలి, ఈ కేసు తీసుకోవాలి. Therefore you are having the second case. So the next 750 length తీసుకుందాం. Now apply the same thing. Let from the figure Q1 is equals to discharge in the first parallel pipe. Q2 is equals to discharge in the second parallel pipe. Discharge in the second parallel pipe. Then what is the formula for parallel connection? Q is equals to Q1 plus Q2, right? So Q is equals to Q1 plus Q2. Now the discharge Q is a main pipe flow discharge anamata, but as the length and the diameters of each parallel pipe is same, Q1 is equals to Q2, that is equal to Q by 2. ante kada? So from the figure Q by 2 ante 750, ante 750 is equals to Q1 is equal to Q2. Q1 is equal to Q2 is equal to Q by 2. Now considering the flow through the pipe ABC or ABD. So ఏం చెప్తున్నాడు? ABC కానీ ABD కానీ. So why? Because ABC నుంచి exit same, ABD నుంచి కూడా exit same. Therefore we can take any line, ABC line or ABD line. Therefore head loss in the ABC is equal to head loss in the AB plus BC. అంతే కదా? The head loss through ABC is head loss through ABC is head loss in the AB plus head loss in the BC. ఇప్పుడు రెండు కేసెస్ వస్తాయి అన్నమాట. Now but a head loss due to the friction and the 0.3 meter is given. Therefore a head loss due to the friction through AB is equals to 4 into F into L into V square by diameter into 2 into 9.81, where V is equals to velocity. Now V అక్కడ AB అన్న పెట్టుకోండి, స్మాల్ గా VAB స్క్వేర్ అని పెట్టుకోవచ్చు. Therefore Q by area, that is equal to Q by pi d square, that is equal to 40 by pi into 0.36. Now the head loss through the friction AB, that is E value, this 4 into 0.1 into 750 divided by 0.6 into 2.81. So V value. So there V is equals to Q by area. VAB is equal to Q by area. Therefore V value ఇక్కడ ఉంది కాబట్టి so దీని స్క్వేర్ తీసుకోండి. Now you are getting 31.87 Q square. 31.87 Q square. Now taking the second one, BC దగ్గర తీసుకోండి. Take the friction at BC, that is equal to 4 into F into L1 into V1 square by D1 into 2G. So V1 వచ్చేసి BC pipe. Okay. Now 4 into 0.01 into 750 divided by 0.6 into 2 into 981 into V1 and the same Q by 2 into pi 4 by 0.6 square. Since V1 value is equals to distance by this కాబట్టి ఈ వాల్యూ తీసుకున్నాడు. Now సేమ్ ముందు ఎలా తీసుకున్నాడు, సేమ్ ఇదే కేసులో ఇది కూడా తీసుకున్నాడు. Therefore 4 into 0.01 into 750 divided by 0.6 into 2 into 9.81 into ఇది పైకి వెళ్ళి ఇదంతా ప్రాసెస్ జరిగిన తర్వాత 7.969 Q2. ఓకేనా? సో దిస్ ఇస్ ద సెకండ్ కేస్. Now substituting the values in the equation 2. What is the equation 2 here? The equation 2 is head loss in ABC is equals to AB plus BC కాబట్టి ఈ 31.87 whole square plus 7.9 ఈ రెండు యాడ్ చేయాలి. Therefore AB is equal to 0.3, 31.87 ప్లస్ 7.9 ఇది ఈ రెండు యాడ్ చేస్తే 0.3 is equals to 39.839. Therefore, Q is equals to root of 0.3 divided by 39 into 39.839. That is equals to 0.0867. Right? So that is a general discharge. Therefore, the increase in the discharge, the increase in the discharge the increase in discharge is equal to Q minus Q. So మనకి ఇది వచ్చిన వాల్యూ, రైట్? therefore వచ్చిన వాల్యూలో నుంచి so that is 0.08867 minus 0.0685. So where is this 0.0685 has come? 0.0685, this one, the discharge Q star. నార్మల్గా డిశ్చార్జ్ మనకి ఎంత వచ్చింది? ఇంత వచ్చింది. క్యాలిక్యులేట్ చేసిన తర్వాత ఎంత వచ్చింది? ఇంత వచ్చింది. therefore minusing this one, we are getting 0.00182 meter cube per second. That's the value for this problem. So this problem will be given for 8 marks, or the pattern is changed directly for 15 marks answer. So parallel questions lo you are getting this type of problems also, right? So hope you understood the problem kada. Next 11:30. So we're having 10 more minutes. So we'll see third question. Yes, we'll see this question. A pumping plant forces water through 600-meter diameter main pipe. A pumping plant has a major pipe that is 600 diameter pipe. The friction head is 27 meters. In order to reduce the power consumption, it is proposed to lay another main of the appropriate diameter along the side of the existing one. అంటే ఉన్న ట్యాంక్లో నుంచి మనకి 600 meters పైప్ ఉంటే సో పవర్ని తగ్గించడానికి ప్యారలల్గా దీనికి ప్యారలల్గా other pipe has been made, proposed another layout, other appropriate diameter along the side of the existing one, so that two pipes may work in a parallel for the entire length and reduce the friction head of to 9.6. Initially the friction head is 27 meters. ఇంకొక pipe parallel పెట్టినప్పుడు the head has been reduced to 9.6 only. Now find the diameter of the new main pipe with the expansion of the diameter. It is similar to the existing one in every respect. Okay, right. Now what's the given data? So parallel undi kabatti we have to take the concept of parallel formulas. Now what is the given data? The diameter of the single pipe is 0.6. What is the friction head in the initial case? 27 meters. Then friction head for the two parallel pipes. So 9.6, 9.6. Now taking the first case and the first pipe తీసుకుందాం. For the single main pipe, so ఇది single main pipe. సో ఇక్కడ మనకి డ్రమ్ ఉంది అనుకుందాం, ఇక్కడ కట్ చేసి చూపించాడు. సో వీఆర్ నాట్ టేకింగ్ ద హెడ్. ఓకే, నౌ ద ఫస్ట్ కేస్లో ఫార్ములా తీసుకోండి. హెడ్ లాస్ హెచ్ఎఫ్ ఈజ్ ఈక్వల్స్ టు 4 into F into L into V square by D into 2G. సో హెచ్ఎఫ్ వాల్యూ వేయండి, 27 ఈజ్ ఈక్వల్స్ టు 4 into F into L into V square by D into 2 into G. therefore మనకి ఇవన్నీ తెలియవు కాబట్టి ఇవన్నీ ఒక సైడ్కి తీసుకురండి. తెలిసిన వాల్యూస్ అన్ని సాల్వ్ చేస్తే యు ఆర్ గెటింగ్ దిస్ వన్ 79.461. Now we know V is equal to Q by A. Therefore FL into Q V square కాబట్టి Q square by A square is equal to 79.461. ఇది 1 అని పెట్టుకున్నాం. Now second case ఏంటి? Now take two pipes are in parallel. Now what is the loss of head in one pipe? ఒక pipe లో లాస్ వచ్చేసి 9.6 meter. Therefore for the first pipe HF1 అని పెట్టుకోండి, ఫస్ట్ పైప్. సో దిస్ ద ఫస్ట్ పైప్, దిస్ ద సెకండ్ పైప్. సో ఇక్కడ ఇది మెయిన్ పైప్ అంటే దీంట్లో నుంచి ఏమైనది కట్ అయ్యి ఇట్ ఈస్ గోయింగ్ లైక్ దిస్. ఓకే, ఇట్ ఈస్ గోయింగ్ ఇట్లా వెళ్ళిపోయింది అనమాట. So the first case is second case. Second case, so what happens? This Q is split into two cases. That is Q1, this is Q2. Now taking HF1, ఇది HF1 తీసుకుందాం 0.6 meter. HF1 is equals to 4 into F into L into V1 square by D1 into 2G, that is equal to 9.6. Now same. Now L1 is equals to L into V1. We know that L1 is equals to L into V1, that is equal to Q1A1 is equals to Q1A. Now D1 is equals to D is equal to 0.6, where A1 is equals to A, right? Because area is same, right? Therefore 4 into F into L into divided by 0.6 diameter into 2 into G Q1 square by A square. ఈ V వచ్చేసి ఇక్కడ ఇలా రాసుకున్నాడు, V వచ్చేసి, రైట్? therefore 0.6. therefore ఇవి సపరేట్ చేయండి, ఈ వాల్యూస్ మీరు సాల్వ్ చేస్తే you are getting this one. So first case ఏంటి? The first case is like this, first case is like this, second case is like this. Now for the second pipe, second case లోనే second pipe తీసుకుంటే సేమ్ ఫార్ములా వేయండి. HFT is equals to 4F into L2 into V2 square by D2 into 2G, that is equal to 9.6, where same L2 is equals to L into V2, సేమ్ ఇట్లా వస్తుంది, రైట్? సేమ్ ఇది ఎట్లా ఉంది, ఇది అట్లనే ఉంది. నౌ సేమ్ ఇట్లనే వేయండి, 4 into F into L into Q2 square divided by 2 D2 into 2G into A2 square, that is equal to 9.6. సో దీని ఎలా రాయొచ్చు? వాల్యూస్ అనే సైడ్ తీసుకురండి. 4 into F into L into Q2 square by D2 into A2 square, that is equal to 9.6 into 2 into 9.6 by 4, that is equal to this one. Okay, same. Second case, this is third case. Now dividing the equation by equation 2, then what is the equation 1 here? ఈ equation లోపల substitute the equation 2, this one. What you are getting? Q2 by Q1 square is equals to 79.4 divided by 28.25, that is equal to value this one. Therefore Q by Q1 is equals to root of 2 point, so మనకి Q square కాబట్టి Q ని పంపిద్దాం, స్క్వేర్ అడ్ పంపిద్దాం. Q by Q1 is equals to రెండు స్క్వేర్లు ఉన్నాయి కదా, Q is so కామన్ గా తీసుకుని పంపిస్తే 1.167. therefore Q1 is equals to Q by so and so, that is 1 by 1.6 second the 0.596 into Q. But we know that according to parallel flow, Q is equals to Q1 plus Q2. So అప్పుడు ఏం చేస్తారు? Q1 వాల్యూ దీన్ని సబ్స్టిట్యూట్ చేయండి. therefore Q2 is equals to Q minus Q1, that is equal to Q minus 0.596 Q, that is equal to 0.404 Q. Now dividing equation 2 by equation 3. So dividing equation 2, so దీన్ని by equation 3 చేసినప్పుడు ఏమవుతుంది? ఇవన్నీ క్యాన్సిల్ అయిపోతాయి. ఇవన్నీ క్యాన్సిల్ అయిన తర్వాత ఓన్లీ వాల్యూస్ తీసుకుంటే Q1 square into D2 into A2 square by A2 into Q2 square, that is equal to this formula, this one, this value is this one. So after dividing this one, you are getting a value. Therefore A2 is equals to normal formula ఏంటి? pi by 4 dt square, and A is equal to formula this one, right? Therefore Q1 square by Q2 square into D2 into ఏరియా ఫార్ములా వేయండి, అండ్ కింద దాంట్లో కూడా ఏరియా ఫార్ములా వేయండి, దట్ ఈస్ ఈక్వల్ టు 0.6. ఆర్ వాల్యూ సబ్స్టిట్యూట్ చేస్తే యు ఆర్ గెటింగ్ ద సింప్లిఫైడ్ ఈక్వేషన్. సో ఫైనల్లీ D2 to the power of 5 is equal to 0.6 into 0.36 into 0.404 divided by 596. So the value is this one. Therefore D2 is equals to 0.03 into 1 to the power of 5. Therefore value karte you are getting finally convert into mm. D2 diameter is equals to 512.5 mm. So that is the diameter of the second pipe. Hope you understood. So this is other way of doing the finding the problem for the finding the diameter of the new main pipe if the exception of the pipe diameter is similar to the existing one in every aspect. Hope you understood the three problems. So Any doubts still here? So the time is completed. I'll stop here. So we will discuss the class in the next session. Okay. So meanwhile, open this video again. See the problems, how the problems are going on in the parallel connection. We will discuss the other problems in the next session, right? So if you have any doubts, personally ping me or personally call me, right? So practice the problems so that you will get aware of doing the problems. Don't say by only seeing the problems you will not get. చూస్తే అన్ని ఈజీగా ఉంటుంది, చేసేటప్పుడే only you'll get the problems. That's why practice the problems. I will send the PPT also, practice the problems. So once this video is uploaded in the channel, I will send this link to your WhatsApp group. Open it, view it, and send to the students who are not coming regularly to the class. So thanks for listening to the class. So we'll discuss the topics in the next session. Have a nice day.